Hello, everyone. How are we with people? Is everyone here?
Hello. Sorry, can you repeat?
Is everyone here, more or less?
More or less, but I think we can start. See.
Okay.
So let me stop sharing my screen, and all yours.
Sure. Great. It's already 4 o'clock, so I'll just go ahead. Let me share my screen. This is the one. Yes. Excellent. Am I there?
Almost. Yes.
Okay. Cool. Hope everyone can see me. If you don't, please say so in the screen in the chat so we can work it. Welcome to the second delivery of the Free Flash workshop. It's a series of Grasshopper Python learning tutorials that we've been put out together in McNeel Europe. This is the second delivery of the beginners level. I'm here today with my colleague Bernard from McNeel Europe as well. He's there in the chat and he'll be there answering the questions for you.
Hello, everyone.
There he is. And my name is David Andros. I'm going to be the one that's going to take you through most of this. And this is my screen that you're watching currently. Okay. So last, just to already get things started, last tutorial we saw what are variables and how can we store them and use them in the Grasshopper Python component. We went through the basics of the components, how to add inputs, take outputs outside from it, and do the basics inside the component. Today's tutorial is going to be mostly based on focused on lists, which are nothing else than just a collection of variables. Let me show you something. I'm not sure you can see this. Here it is. Right. Oh no, that's not it. There. So, what is a variable, right? So this is what we saw last week. A variable is nothing else than a container with a certain name that stores a certain value, right? In this case, you can think of it as just a plain box which you have tagged with a certain name. In this case, it's just name, and a certain value, which in this case is just a, right? So what we saw in Python last week is that you can actually define these types and check these types and store whatever types you want in the Python components and use them for certain functionality. Now, on the other hand, what we're gonna you can actually think about lists in the same way. So what are actually lists? Lists is just in analogous ways, nothing else than some sort of a drawer of compartments where you're storing stuff. So instead of having just one box, say you have many compartments where you can actually store these values and actually call upon them and assign onto them as much as you want. This is going to be much clearer when I go through that in Python. Maybe these drawings that I made with my kit are not so self-explanatory, but let's go through Python already. So this time I'm not going to provide any file for you because it's not really necessary. We're going to do most of the stuff from scratch already. And I've just started here by showing what are lists in Grasshopper because as you probably remember, one of the prerequisites to follow these tutorials is to have a certain level of Grasshopper. And I'm sure you already know what lists in Grasshopper are. So you can actually make those type of lists just by inputting many strings in a panel like such, like the first case. You can also create lists in Grasshopper by throwing in a parameter component, like in this case the text parameter, right-clicking on it and setting multiple text and just inputting the same type of items if you would like. And there are also many types of Python Grasshopper components that create lists automatically for you. So the output of those are already lists, like is the case of the series components and the character sequence components. The first one actually creates a list of from zero to whatever you define, a list with certain parameters. The second one creates a list of characters straight away, right? Now, the concept in Python is nothing unlike this. And we're actually going to take this same sort of example to start with, right? So what I want to do, I don't need you guys to create all of these 4 lists. Maybe I'm just going to take one of these, and whichever you want. I'm just going to take maybe the first one. I'm just going to drag it down here, and I'm going to use this to first of all teach you how do you bring Grasshopper lists into the Python component, right? So as usual, the first step is always double-clicking on the canvas or navigating to the math script tab here and bringing in the Grasshopper Python component. And now we can access it. And we already know that we can actually define the input here. So I'm just going to define the input name as, I'm just going to just a fruit list, right? And I'm going to define the type, because that's also what we learned last tutorial. It was super important that we define the type in the input so that Python can recognize it in the inside. So I'm just going to define this as a string, and for the time being, that's all I'm going to do. Now, I'm going to double click on the component so that I can see what's inside, and I'm going to just delete everything from the inside of it because I don't really need it now. And I'm going to just check what happens if I actually input this list directly, right? And I'm going to try to do that, and this is what happens. Let me try to zoom in this a bit further. I can't, but you can see what's going on here, right? The Python component immediately starts to calculate and work with each of these items separately, and thus telling you here in the output that there has been a different cycle for each of these items. And that is because the Python component is not really reading this list as a list yet. You have to actually specify this for the Python component. In order to prove that, as usual, I'm just going to type by saying lists into GhPython, right? And I'm just going to start by printing the fruit list variable that I've stored here. And as you can see here, what happens is that the Python component prints each of these items separately, not as a list. So it actually goes through each of these items one at a time, and thus just prints the first one, prints the second one, the third one, and so on and so forth. And that's not exactly what we want here. What we want is to actually tell the Grasshopper Python component that we want to have a list access, like such. So this is super important to start working with lists. We have to define that it's a list here. And things change now, right? Now we actually have the list that we have from Grasshopper inside the Grasshopper component here, as you can see. As usual, we can check that by saying what type of element is this, right? There you are. And we're going to get the type of a list, right? That's what we want. You can see that if we don't do this, if I just leave it to item access, then I am actually reading each of these as a separate item. Thus, the type is a string every time, right? So it's really, really important that when you want to input a list into the GhPython component and you want to work with it as a list, you always tell it that it's a list in here. Okay, great. Perfect. Now, like in the previous tutorial, I'm gonna be commenting things out a lot so that I can actually reuse them. I'm just gonna comment these two out first. And I'd like to teach you first how do we access items in a list, because maybe what we usually want to do is not do things to the list per se, but actually do things to the items in the list, like we would do in Grasshopper, like do one thing to the carrot item, one thing to the weight item, one thing to the other, and so on and so forth. So in order to access items in a list, we use the so-called bracket notation, which means, for example, I'm going to create just a first variable here, which is going to be called first fruit, or whatever you want. And in order to access the item in a list, I'm just going to input the name of the list and open a set of brackets here. And this is called the bracket notation. And I'm going to specify here which is the item that I want to access and assign to this variable called first fruit. So since I'm actually trying to access the first fruit, I want to actually input the 0 item here. And if I print this variable, of course, I'm going to get nothing else than the first fruit. Now, be careful and remember this always. As in Grasshopper, as in the Grasshopper panel, the Python lists also work the same way. The index always is a sequential list of numbers, which starts from 0 and not from 1. So the first item is going to be 0, the second item is going to be 1, the last item is going to be 4, even though the list is composed of 5 items. So if for instance, if I say, let's say, for example, I'm just going to print straight away this time. Fruit list item number 1. First, I'm going to get apple. If I print item number 4, I'm going to get onion, right? And that's the way it works. This is not shouldn't be too hard to grasp, right? Now there's a really actually really cool trick to access the last item without knowing the length of the list. For example, if I would like to access the last item in this list, so say, for example, last fruit, I can actually use a negative number here. And if I print it, it's going to actually always access the last item in the list, regardless of the length of the list, which means I'm actually telling Python, hey, start counting from the backside, from the end of the list, and give me the -1 number, or give me the -2 number also works, for example. Then I'm going to get the second to last, or -3 is going to be the third to last, and so on and so forth. So this is actually a nice way to access the last item in the list without knowing the length of the list, which is usually common for other programming languages. Be minded, I'm not too careful into looking into chat. So if there's anything that really needs my attention, just please give a shout out to Bernat, and he'll say something to me, or Bernat also, if there's anything that you think needs my attention, let me know. Okay, that's easy and straightforward way to access items in a list, right? It's no different than the list item component in Grasshopper, where you specify an item and then the component gives you back a list. This is the same for this, right? Now, let me just output this. Well, actually, let's say I want to actually replace an item in the list. The process for replacing items in lists is a bit tedious in Grasshopper, but in Python it's quite straightforward. Let's say I want to, let's say, replace item number 2. I want to replace grapes with another item, which is going to be called tomatoes. Okay, I'm just going to output this put list outside of the Grasshopper component so it's a bit more visible. There. I'm actually not using the Rhino canvas to the Rhino layer anymore. So there, I've actually I have managed to replace, you see, the second item, which is the grape item, with a tomato item, and so on and so forth. And of course, this works for every other item, and it also works for every other type. So let's say, in this case, I am actually going to use a slider from let's say from 0 to 4, which is the length of my list. No, actually, let's do something. Let's actually do it the wrong way so that we can see. I'm going to create another input here, which is going to be called item. As always, I'm always going to set it to the type that I want. In this case, it's going to be an integer. And I'm going to use this item in order to access this variable, in order to access the item on my list. Right? And I'm going to replace the one that I'm selecting here with a value. In this case, it's going to be an integer. Just to show you that Python lists, they actually can mix types within them. Unlike C# and maybe other programming languages, where this is not really straightforward. In Python, you can have a list that's composed of, let's say, strings and integers and floats and curves and points and whichever type that you want. You can actually store them all together in the same list. Now, as you can see, I've created a sort of select item replace component here, where I'm inputting a list and I'm actually replacing the item that I select with a slider. But be careful. What happens if I go overboard? If I select an item that's past the length of my list, like 5, since there's no item 5 here in my list, I am going to get an error from Python, and that says, hey, the index is out of range, as you can see here. There is actually no item number 5, so I cannot give you anything. And the Python component gets angry and red, and it's not going to work. So make sure that when you do this, you always limit yourselves to maybe the length of the list, which if you know it beforehand, then in this case is going to be 4, right? Okay, easy enough. That's how you bring lists from Grasshopper into Python and select them inside of them, right? Now, what about creating lists already from the Python component? As usual, we're going to bring another component here. And in this case, I'm not going to be changing anything from the inputs because to start with, I'm just going to create the lists from inside the component itself. There we are. Let me delete this and give me just a second. I'm going to check the chat. Let's check if everything is going well. Seems so. Okay, great. Now, how do we create lists in Python from scratch without having to bring them from Grasshopper? A bit of a mouthful title, but yes. So of course, there are really many ways to go about this, but I would say the simple and the most common one is to create an empty list, and you do so by assigning, as usual, any variable name that you want. Like maybe in this case, it's going to be like empty list, and this is the way that you have already told this variable that this list is an empty list. This is just if we come back to my drawer example, this is just like an empty drawer with no length, with no values inside it. It's just kind of like a drawer waiting to get stuff inside the lists, right? Now, what if we try to actually insert items with a bracket notation? Let's say I'm just going to say I want to assign the 0 item to this list to a certain value, let's say 40 or whatnot. Now, if I press test or F5, of course, this is not going to work because since the list is already empty, it doesn't even have a 0 item in it. It doesn't have anything on it. So I cannot actually assign to the 0 spot, because there isn't really a 0 spot to begin with here, right? So this is something that doesn't work. So in order to fill in the lists, so let's say, sorry, my keyboard is a bit crazy. Add items to the list. I need to actually figure out another way to add them. And this is by using the append function. In this case, let's say, for example, I'm just going to append a string, which is going to be called nuts, right? So what append does is adds this variable, whatever I put inside here, to the last position of the list. In this case, the last position is also the first one because it's actually the same position. But let's say if I actually append again another word, let's say anymore, another variable which is called anymore, then I'm going to have actually a list that says not anymore, right? And a list of 2 items with 2 values. One of them is not, the other one is called anymore, right? So this is the way that we start to fill in lists in order, let's so to speak. So we just add them to the end. But there's actually another way to start filling the list, which is actually inserting items. And this is by using the insert function of lists, which I'm going to simplify here. So instead of using append, in this case, I'm going to use another function which is called insert, which actually not only asks me for the variable. Let's say in this case, I'm just going to say empty, but also asks me for the index position of where I want to insert. In this case, let's say I want to insert the word empty right in the middle. I'm going to start by inserting in the one index, which is actually 0, 1, right, right in the middle. And therefore, I'm going to get a list that is called, let's just say it's not empty anymore. It's just 3 different variables inside the list, 3 different items. The last one has been inserted in the first position. Of course, if I do insert it in the first position, it's going to be empty, not anymore. If I do this in the second position, same, so on and so forth. This is another way which I can actually start to fill in variables to my lists. Okay. I'm going to comment all of this, and I'm actually just going to show you a trick here to comment lots of lines in GhPython. I can actually select all of them and press Control slash, and then all of them get automatically commented. If I press Control Z, they're going to go back, of course. If I press, I'm just going to say it again. I select all of the things that I want to comment, and I press Control slash, and then everything gets commented. If I press Control Shift slash, Control Tab slash, sorry, Control Tab slash, deselect, decomments the list. This is just a quick trick to comment everything in one go. Or maybe I also take the opportunity to show you another way to comment blocks, which is by using the, sorry, this is my keyboard, which I have to continuously change languages, by using the triple quote in the beginning and triple quote in the end. This also works as a comment. As you can see, everything got commented here, so, but everything that's in between 3 double quotes and 3 double quotes, it's also another way to comment things on Python. So you can actually use either or both. And this is just kind of a parenthesis in the middle of the list thing. In any case, the important thing is that you have this commented out one way or the other, because I'm actually going to teach you another way to initialize the list. Oops. Switch back to another language. There we are. And I'm going to say this time initialize list with items already, right? So say I want to create a list that is going to be called odd numbers, right? I can actually open the brackets and start by filling in already items like such, right? So I have just created now a list that brings me the odd numbers with 1 digit odd numbers. But of course, I'm missing 9 here, so no problem, right? I can actually use the append function already, the one that I showed before. And append, if I actually append 9 to it, it's going to add 9 as a variable to the end of the list. So now I have actually the 5 one-digit numbers from 0 to 10, odd numbers from 0 to 10, and that's actually great. That's perfect for when you already know what items that you want to have in the list, but that's actually rarely the case, I think, from my experience in Python. Okay, I'm just gonna also go ahead and comment this out, and maybe start printing stuff down here. Now I'm gonna teach you another way to create lists in Python. It's through the range function, right? Which is actually similar to the series component in GH. And I'm gonna prove it to you. So I am gonna create, in this case, a list that's gonna be called sequence. And I'm going to use this function called range, right? And if I open the parentheses, it already gives me a hint. So this actually happens for most of the functions in Python. When you access a function that Python knows about, and you open the parentheses, it gives you a little helper here, down here. It's called a help unbuilt function of the function itself, and it tells you what kind of stuff can you do with it, right? So for the time being, we're just not going to pay any attention to this. I'm just going to input 1 to start with, and I'm just going to explain how this works. What happens if I print this? Right? If I print my sequence, what the range function does is create a series of numbers from with the length of the number that I specified here. In this case, I'm just saying, give me a list that has 1 item, right? And in this case, the default is that it starts with 0, of course, and it fills in 1 item, right? Now, what if I do this sequence equals range of 10? Print it. Now I'm going to get down here a series from 0 to 9 because I'm saying, hey, range function, give me a list of numbers from 0 to 10. Give me 10 numbers that start from 0, right? And this is actually the first 10 numbers that starts from 0 to 10. So this is the default of the range function. It works like this. It always starts with 0, and it actually gives you the number of items that you specify here. And stepping, of course, 1 item at a time, adding 1 to each variable at a time, right? But you can actually tweak this manually by saying, for example, oh wait, hold on 1 second. You also might notice here that I have overwritten the variable, right? So I created the sequence list in the first place here, printed, and then I have actually used the same name to create another list, which is from 0 to 10. Just a heads up, you can do that in Python. It's no issue. You can actually, everything that you have replaced, that you replace, overwrites the previous stuff. So in this case, everything that from line 32 forth, whenever I refer to the sequence variable, it's going to refer to the last thing that I have assigned to it. In this case, it's going to be, of course, a list from 0 to 10. What if I want to create a sequence from, let's say, 3 to 6, right? I can actually use the same logic, but in this case, optionally, I can also tell the range function, hey, I want the series, the list to start with 3, and I want it to stop before 7, right? So it actually gives me a number that a list that starts with 3 and stops before 7. And that's how it works. When you input 2 numbers, that's how it works. It means starts and stop, right? I can actually go even further and more similar to the series component and say, for instance, what if I want to create the list of odd numbers? Right? In this case, I would actually need to skip one item instead of creating a list that's sequential, adding one number. I can say, for example, give me a list that starts with 1, ends before 10, and skips every 2. Right. So if I print this odd numbers list, I'm gonna get the list with every odd number from 0 to 10, like the one I've created before. Maybe a easier way to this is super useful. This range function is going to be very, very useful in the future when we look at iterations and for loops, because the range function is used a lot there to create lists in one go. Now, let me just show you. I'm just going to comment this out, and we're just going to try to recreate the series components here with the same logic. And this time I'm just going to create a list called series with the same logic. And the first item is going to be it's going to be a variable that I bring from the outside that's going to be called start. Another one's going to be called stop, and another one that's going to be called step. Now, in the GhPython component, I'm just going to bring in a couple of sliders here. And I'm going to create one input that's going to be called start, another input that's going to be called stop, and I'm going to add another one that's going to be called step. Right? Now, don't forget, this time I'm just using items, so I don't need to assign any lists access to it, but I do need to tell the Grasshopper component that it's an integer, as usual. So this is something that you must do every time, and never forget, because most of the issues come from here, from forgetting to tell the Grasshopper component which item it is, which type of the item it is, right? So let's just output this series list that I'm creating. That's actually a sort of a dynamic list that I change with sliders. And what I've done here is actually done nothing else than replicating the series component in Grasshopper. So I'm saying, for example, create a list from 1 to 7. So let's say a list of 7 items, right? From 0 to 7, or from 0 to 10. And I actually wanted to skip every 2, or every 3, or every 4 items, right? So start, stop, and step. This is probably the best way to actually understand what's going on in the range function here, right? I can make a list that starts in 2, in 4, and maybe it gives me all of the even numbers from 2 to 10, and then it's actually going to give me 2, 4, 6, and 8. Okay. Okay, great. So that's basically the most basic way to create lists from the GhPython component. And this is something that we're going to be using a lot from here forward, because the range function is one of the basic components of the for loop iterative and other iteratives that we're going to work with. Great. Now there is one other thing that I'm gonna show you quickly. It's called slicing, and this is actually also steps into a proper way to copy lists. Okay, So for this, I am gonna, as usual, bring in a grasshopper component here, and I'm gonna make a panel, a quick list of names, which are gonna be, let's say, for instance, I'm just gonna say Bernard, Delia, Carlos, Daniel, Carla, okay, which are my colleagues from McNeel. Remember always to use the multi-line data here to convert this panel into an item list. And I'm going to use this panel to bring it inside to the Grasshopper Python component. First by plugging it into the input, then changing this input to something familiar like names. And of course, the two steps that I should never forget, specifying the type, which in this case is string, and specifying that it's a list, in this case, list access. Okay, cool. Now I'm going to use this inside of the Grasshopper component here. And I'm going to actually show you a quick way to slice the list, which slicing actually doesn't mean anything else than taking certain parts of the list, the parts that I actually care for. No, this is similar to certain components here in the Grasshopper component list, set list parameters, like the partition list, for example, or the split list. This will give you a portion of the list which you can actually specify. But to be honest, in Python, it's much faster, much more straightforward. And I usually use this slicing feature a lot for for selecting certain items of the list. I'm just going to say slicing, and just to put a title to it. And I'm just going to show you what a slice is very quickly, right? So let's say I want to. I just want to make sure that I have the list here properly. And if I print names, just want to make it a little bigger there. If I print the names, I'm going to get of course, I'm going to get the list from Grasshopper inside Python, and I already have it here. Good. But what if I actually want to only take the first two items of the list? And the way to do that is by using this nice slicing feature, which is actually used by the colon here. So if I say, for instance, give me the first two items, column 2, this is equivalent to saying to Python, hey, I want to have all of the items before the second one, before the second item. So in this case, it's going to be Bernard and Delia, right? So this is a nice quick way to, for example, get as many items as you want, 2, 1, and so on and so forth. Now this is a way to get up until index 2. Right. It actually works the same in the other direction. What if I want to get, let's say, for example, all of the items before this, no, before the third item. So actually from index 3 and so forth, right? Then I can tell the Python to give me a list which is sliced in the third index, and gives me from the third one, from the third one and up. So in this case is actually from index 3 and up. Now this is actually a very nice way to select portions of the list, and you can imagine that you can actually plug in a slider here in the Y variable and start to play with and get portions of the list, just like the sublist component here. But it's actually even more useful for other case scenarios. For example, in this case, let me just put a couple of sliders here. For example, the sliders from, in this case, I'm going to be very explicit from 0 to 4. And I'm not going to even rename these inputs. I'm just going to leave them as X and Y, but I want them to be the other way around. There, X and Y. Sorry. There, a little better. Of course, this is going to be items which I specify that are integers. And to show you this, I can also say slice the list, let's say from X to Y, not only from the specifying the beginning and the end, right? So let's say, for example, I want to get the list from item 1 to item 4, right? Being 4 being the last item, of course. Like then I get actually 3 items in between, so I actually get Delia, Carlos, and Daniel, right? So this is actually from 1 to 4. If I expand this a little bit, I also include Bernat here. If I should actually maybe increase this into 1 more, I can also get Carla, right? So you can see you can get slices of the list by this functionality, which is actually quite nice. But furthermore, this is even more useful for another reason, which I'm going to show you. Right? So let's say I want to make a copy of this list, and I'm just going to say, give me a copy of the names list. Right? Now I'm just going to print names. I'm going to print names copy. Comment these two out first. Open this a little bit more. There we are. Now I have just made a copy of the list, allegedly made a copy of the names list by assigning this names list to another variable here, right? Now let me show you something. What happens if I actually append, let's say, another name to the names list, which in this case is going to be just Luis. Okay, what happens if I print both? This is gonna come as a sort of a mystery to you, but what happens actually here is that the first list, the list that I copied in the first place, the names list, also gets the Luis item on it, and that is because this is actually when you assign one list to another, you are not actually doing a copy of it. You are doing a reference to it. And this is a concept that it's a little bit more complex to explain in programming, but it's nothing else than saying that every time that you assign another name to the list, it's just basically giving it another nickname. It's not copying the list into a different item. In order to prove that, I'm going to show you how to do this. For example, I can actually print names and ask Python if it's actually equal to names copy. Right? So here I'm actually asking Python, is names equal to names copy? And Python is going to tell me true. This means that they are actually the same item. In order to prove this further to you, I'm just going to use this ID function that's in built Python function and plug in the names object, which is a list, and it's going to give me the ID of the list, which actually changes every time that I press test. But you're going to see that they actually both have the same ID. If I print the ID of the copy that I've made, they share the same ID every time, and that's why that actually means that the copy that I've made is only a reference to the other list, and it's not a copy itself, right? Now this is where slices come very, very handy. I'm gonna comment this out again, and I'm gonna show you how to actually copy a list, and not only reference a list with another name, but actually make a hard copy of it, right? Now, in order to do so, I can make a variable called names copy, right? And instead of only assigning the name to it, I actually slice through it entirely, which means just using the column to go through to the list completely. That means that I am actually selecting all of the items within the names list and assigning them to this new variable called name copy, right? Of course, if I print names and print names copy, they're both going to be the same. Now I'm going to repeat the procedure from up here. and append list to it, and then actually print them again. Now, as you can see, the two lists are different now. They're not the same list, and that means actually that they're not the same list. This is actually a hard copy of the other list, and I can actually manipulate it, add to it, subtract from it, and the other one won't be affected by these changes. Again, in order to prove this, let's say grammatically, I can just print if this list is equal to the other one. Python tells me they're not equal, it's false, and they also have a different ID. The names object has an ID of 50, and the names copy object has another ID every time. Okay, now this is, I'm explaining all of this because this is a question that comes quite often also in an issue when you're trying to just assign one list to the other, and you get unexpected results when changing one of the lists. And maybe the whole explanation of copying by reference and copying an actual object could be explained in a further chapter, but for now, this is what we're gonna stick with. Okay, so we have 15 more minutes, and I think it's enough to finish what I have set out for. Let me just get some water. Cool. How are we doing? Is everyone good? And if you have any questions or anything of the sort, please do let us know. Cool. All right. So now I'm gonna dive into another concept, which is a concept that it's actually simpler than it usually looks like, and it's the nested list concept, right? For this, as usual, again, I'm just gonna bring another GhPython component here, and I'm gonna create I'm gonna recycle the names that I have from here. Why not? I'm gonna use this. I just copy the panel from up here because I'm gonna use it again. And in order to make another two sets of lists, I'm gonna use the series component in Grasshopper. This is just a series component. And I'm gonna use the character sequence component here and bring this to, right? These guys automatically, as I mentioned up there, the first one gives me a list from 0 to 9, just like the GhPython component that we made. And the other one gives me a list of characters from A to J, 10, let's say the 10 list of characters. Right? In order to specify this length, I can actually plug in a slider here, one here and one here, and I'd be able to change the number of these lists, as you probably already know. But not just, I think you just answered in English, in Spanish, so it'd be good to be answered in English just in case someone else is wondering the same thing. Okay. Okay, so I'm going to rename this item, these inputs, and I'm going to stick with names for this one. List. I'm going to call this other one nums, and another one called characters, chars for cars, for characters. Right. I'm going to plug in these lists, corresponding lists to each of these. There we are. And also, of course, always always remember list access and the type. In this case, the first list is a list of strings. The second one is a list and a list of integers. And the third one is a list, and it's also a list of strings right here. Okay, great. So what about nested lists, right? In this case, a nested list is nothing else than a list of lists, right? Now I get usually get a lot of issues with this chapter with this topic from my students and a lot of questions, but the topic is actually much simpler than it looks like, right? I can actually print names, print nums, chars, and I'm gonna get the 3 lists separately, right? So now I have actually printed each of these lists separately. But in order to make a list of lists, I can actually use the method that I showed you to already include the lists in the first place. To create one such list of lists. If I print this, then I'm going to get one rather large list, which contains 3 separate groups.
David, can you zoom a little bit to the script, please?
Sure.
Thank you.
Hope that's better, but unfortunately I cannot zoom the output part, so you're gonna have to just try it out for yourself. Sorry. There. I have just actually made a list from the 3 lists already, right? So if I actually access the items of this list, if I print list item 0, it's going to give me, of course, back. It's going to give me back the first list altogether, right? That is actually quite straightforward, right? I'm actually just accessing the list of names that I have here. But what if I actually want to access the first item of that list? Then maybe I can assign this and say first. I can actually say, just say it straight away, no? List of lists. 0. First, I'm telling it first access the first item of this, the first item of the whole list, which is the first list altogether, and then give me the first item of that list already, which is Bernat, right? So this is in the beginning a little bit confusing to understand, because you can actually, if you would have a list of list, you can actually keep going forever with this. But it's nothing else different than specifying chapters, for example, in a Word document or anything that has such a tree structure. You can actually access the tree structure by specifying the most high level item on that list, and then the lowest level item here. If I would like to access, let's say, Carla in this case, I can actually say, give me of the list number 1, give me the -1 item, and it's going to give me Carla here, down here. Okay. Now, what if I want to output this list to Grasshopper? This is another tricky aspect of it. And if I just assign this to the A output, I'm going to get this bunch of IronPython runtime lists. And this is not really useful for doing anything in Grasshopper, because the Python component doesn't automatically know how to translate Python lists to Grasshopper lists, and you have to do that sort of manually, right? By using these, by using a library called import GhPython. This is a really useful library that's been implemented into the Python. It builds the GhPython editor and use the dot notation to access the tree helpers. And in this case, I'm just going to nickname this one as th. That is only to say that every time that I press th, it would be equivalent to writing this whole thing, right? It's just a nickname to access it quickly. So in order to access this list of lists to Grasshopper, it's as easy as saying th dot list to tree. Then I'm actually telling the Grasshopper, the GhPython component, transform this list into a tree that Grasshopper can read. And then the list is output as a tree, right? Okay, so no mystery there. I'm just gonna quickly, I think I'm running out of time a bit, so I'm just gonna quickly go to the other kind of useful functions that you have for our lists. And for this, I'm gonna throw another GhPython component, and maybe for the sake of speed, I'm gonna bring this list again, right? And maybe the list of numbers too. I'm going to do again the same procedure. Boring as it sounds, you get really used to doing this quickly. Strings, in this case, is going to be nums, list access, and integers. Okay. Now, we have already seen some inbuilt functions. Very useful. We have already seen some inbuilt functions for the list, like append and insert, which add the items to the end of into a desired spot in the list. But I want to show you how to access these functions. Access list functions. You can actually see all of the list functions that there are available for all of the lists by typing lists and then dot. And by doing so, you get displayed all of the functions that every list have embedded onto them, more or less, right? That's actually how you display all of the stuff that you can do. I'm just going to comment this out so that we can start seeing some examples. Let's say, for instance, I want to get the length of a list. I can actually print the length of names and print the length of nums. The length of a list is nothing else than the number of items that you have. Also really useful for iterations. So you can automatically and parametrically know the number of items that you have stored in a list. You can actually do more stuff like that. For example, sum the items in a numeric list. In this case, you can actually use the sum inbuilt function of lists. And if you pass in a numeric list, like the number one here, you're gonna get the mass addition of all of the items in this list. For example, in this case, is, as you can see, it's actually all of these numbers. This is actually the mass addition of all of the items in the list. For example, if I set this to 2, then it's just adding 0 and 1, right? Another useful thing is getting the min and max value. For example, if I want to assign this to the minimum value, I can actually get the minimum value of a list with the min function and get the maximum value with the max function. Here, if I print max, then I am going to get, oops. Of course, yeah, I've gone a bit too far in the list. Int is not callable. Yeah, sorry, I forgot to press play. There we are. I've also probably gone a bit overboard here. There we are. Right, so I am actually getting the minimum and the maximum number of that list, which is really useful for when you got a really long list and you don't want to sort it and see the 0 item and the -1 item. Right. I'm running out of time here, so I'm just going to finish this quickly. Let's say I just want to output these names here. Right. There are certain other functions that you can do to lists, like for example, pop, which actually removes an item from the list. In this case, you specify the index. With the pop function, if you specify the index, as you can see, I have just removed the item number 3. which is Daniel. Sorry, Daniel, you're out from the list here. With pop, you can actually also specifically remove an item by specifying which item do you want with the remove function. For example, let's say I want to remove Carlos from the list. Carlos is gone now. If you actually, this one would only work. This won't work with when you have actually repeated values, and you would only remove the first one at the first one that the function encounters. So you have to do that for as many repeated values as you have. What if I want to reverse the list? Same as in Grasshopper, names.reverse. Actually, as you see, it turns around the items in the list. These are all akin to the Grasshopper set components that you have up here. You can do the same with the list. And finally, sort a list. You can actually sort them alphabetically or numerically as well, from lower to higher with the sort function. Okay, and that's it. 1 minute passed, and I think I've covered pretty much everything that I want to cover. It's been
Sorry, there's a question, David. If you check the chat.
Oh yeah, sure. Oh, then. Okay.
If you can show the 3 helpers again.
Right. 3 helpers, of course, here. Yes. So, Stefanos, what I've just done here, I'm gonna just do it again.
Zoom in a little bit, please.
Here is just imported this library, which is called GhPython live, and then access a sub-module of the library with the dot, and then selected 3 helpers, right? But in order to not be typing on this mouthful every time, I have just specified a nickname for this called asth, right? So what this asth does is actually just the same as just saying GhPython dot, you see? The th is just sort of a nickname to not have to write the whole thing, but just saying th. And then I can access the list to 3, list to 3 function, which is the one that I'm using below here to convert a Python list to a tree. Okay, is that clear, Stefanos? I hope so. Okay, great. Is there any other questions for you guys? This is the time. Hopefully I can answer some of them. Otherwise, cool, great.
Yeah,
otherwise,
no questions.
It's been a pleasure showing you some of these functions. It's been sort of an in-depth session on lists, which, believe me or not, is going to be really useful in the future. All of the sessions are sort of very, very specialized in one topic, and the next one hopefully will be the same. If everything goes right, then we will have another session next Wednesday, and we will also post this video in the meantime so that you can go through it. Thanks a lot for attending. Thanks, Bernat, for being on the dark side.
No problem at all.
And see you guys hopefully next week. Then stay safe and cheers.